to my poster presentation. I will be talking to you briefly today about a semi-unsupervised machine learning system for gait event detection, locomotion mode, classification, and prediction. I will be talking briefly about the key findings of this study, as well as the results, introduction, data collection methods, computational methods, and discussion can all be found on this slide and the final slide. Furthermore, if there are any questions or comments, please feel free to leave them in the comment section below, in the ASB forums for the 2020 conference, as well as feel free to send me an email. So, the key finding for this study is that we demonstrated the output from the beta process autoregressive hidden Markov model can be utilized to identify gait events. And information between these gait events can then be input into a long short-term memory network for the classification and prediction of transitions between multiple locomotion modes. I'd like to draw your attention to the fact that the beta process autoregressive hidden Markov model is an unsupervised feature extraction algorithm, while the long short-term memory network is a supervised algorithm that can be used for either classification or prediction. We use them for both in this case. Table 1 shows the percentage of identified initial contacts and toe-offs. Here, for all foot contacts, we were able to identify approximately 99.61% of initial contacts and 99.63% of toe-offs. The temporal differences between initial contact and toe-off are shown here. The goal of this was to identify initial contact and toe-off approximately 40 milliseconds prior to a gait event, and we have achieved that with the initial contact difference between estimated gait event and measured gait event being 60 milliseconds on average, and the toe-off difference being approximately 90 milliseconds on average. Here in Table 2, we show the identification of the locomotion mode of a transition step. Classification of the transition step was above 90%, and prediction of the transition step was above 93%. For steady-state locomotion mode classification and prediction with LSTM output, we have approximately greater than 92% accuracy and greater than 96% accuracy for classification and prediction. For figures 3 through 8, there are 3 panels, which have the panel A has the true foot contact and angular velocity, panel B has the true foot contact and the output from the beta process autoregressive hidden Markov model, and panel C is the average state duration for the 3 steps prior to the transition step and post-transition. We have the walk to run and run to walk transitions here. We have stair descent and stair walking and walking to stair descent here. We have stair ascent to walking and walking to stair ascent. Here is my final poster. Thank you very much for your time.